Hello students, welcome back to my channel. This is a new lecture on the topic soil texture, which comes under the branch of soil physics. So we have seen an introduction for the soil physics in the previous video. In this video, I have to tell you about the soil texture in depth, so we can go directly into the lecture. You can see three pictures, right? In the first picture, um, these three are soil, different types of soil. So in this first picture, the soil flows through the hand very easily, and minute particles we can see, right? Is it? So in second picture, that soil while it is in the hand, it will look like, or we can feel like a flour, like a wheat flour, the one which is used to make chapati. So it is like powder. mm? And the third picture, you can see this soil is sticked. It is sticking to the hand of these two hands. So it is dry, wet soil. So these all three soils are very different, and when we touch the first soil from the first picture, we will feel gritty. And this type of soil, it is very gritty when we touch with our hand, and this when we touch it will feel like a powdery, like a talcum powder. And this soil when we touch it, it will stick to our hand. It has that property. So that property of a soil is known as soil texture. So it is a feel when we touch the soil. So this feels gritty. It's a texture is like that gritty. Its texture is very talcum powder, like a talcum powder, and it's this texture is like sticky texture. So that's what we call soil texture. First one is sandy soil, like we see in beaches. Second one is silty soil, and third one is clay soil. So this is known as soil texture. So remember that in this sandy soil also, we have studied the soil separates like sand, silt, and clay. All the soil separates are present. When we hear about sandy soil, we will think that it only contains sand fraction, sand as the soil fraction, but it is not correct. It contains all the three fractions, but their amount will be different. And amount, more than amount, we can say its property, the dominant property will be different. In sand soil, dominant property will be of sand fraction, and in clay soil, dominant properties of clay fraction. So, soil texture means it is the feel of something. You have to understand this concept first. So, what did I say? A soil contain all the soil separates, but in different proportion. Its property will be in different proportion. So, we call this relative proportion as soil texture. Relative proportion of soil separate is known as soil texture, and it is a property of the soil that cannot be changed or altered, because we can't change the amount of soil separates in the soil. That's why it is a basic or permanent property of soil. It is known as the basic or permanent property of the soil. For understanding the soil texture, qualitatively we can measure, and quantitatively also we can measure. Qualitatively, like its definition is, it refers to the feel of a soil, whether coarse and gritty or fine and smooth when rubbed between thumb and forefinger. Quantitatively, soil texture is a relative proportion of sand, silt, and clay content on weight basis. Since it is not changing, it is a static property. It is not dynamic, it is static property. So in soil texture, regarding soil texture, you have to study it is a relative proportion of soil separates like silt, sand, and clay, and it is a basic and permanent property of the soil. Next, we can determine the soil textural class. That means if we have a soil with us, we can see or we can determine to which what texture that soil have. So there are two methods. First one method is field method or field method. Second method is laboratory method. So suppose I am in the field, I have to determine the texture of the soil of that field. So what I will do, what I can do, I have to take that soil and keep it between my thumb and forefinger. So first of all it should be moist, okay, then I have to rub it. Then if I rub, if I feel gritty and if I can see the particles very easily, then that texture will be sandy texture. That soil will be no, its texture will be sand, and it can that particular textural class that soil belongs is sand, sandy soil. Then if I can feel like it is a talcum powder when dry and slightly sticky when wet, slightly sticky but not very sticky when wet, it is a silt. It belongs to silty class. We can't say silty class. If a soil dominates the silt, then this property will be there when we touch it. Then if it is very plastic, then sticky when wet and hard when dry, then it is clay. Okay, so this method is known as field method and it is done in the field. So it is also known as field method. Okay. Next, I will bring this soil from field to laboratory. So in the laboratory, we have a method. So that method contains two process, two steps. First, mechanical analysis, then by using textural triangle. So in mechanical analysis, we will know how much percentage of sand, silt and clay is present in the soil, and with that percentage, when we know that percentage, we will use a textural triangle. From that textural triangle, we can find out which soil textural class to which soil textural class our soil belongs to. Okay, so there are two methods. First one is field method or field method. Then second one is laboratory method. That means mechanical analysis followed by using a textural triangle. So we can see the mechanical analysis. Then how to do mechanical analysis by step. We will see it is a process of determining the sand, silt and clay content in the soil sample. So we will get the percentage sand, silt and clay content. So suppose I have a soil sample with me. Then in a polythene cover, I brought it from the lab. So when I opened it, what I can see? I can see soil, the large rock, pebble, roots, etc. But I don't need this because these are greater than 2 millimeter diameter and we are not using it. It is a waste. We can't say waste, but we can't use it. So what I will do? First, I will take 2 sieve. Sieve, you know, everyone know what is a sieve, is it? So with this 2 sieve, I will screen and remove large rock, pebble, roots. Okay, so if it is 2 sieve, which particles will flow through or which particles will come through that sieve, filter to that sieve less than 2 size particles. So that kind of particles are needed for this mechanical analysis. So first we will remove large rock, pebbles, roots, okay, through 2 sieve. So I got a soil. That soil separate contain less than 2 millimeter size particle. So I will take that soil and I have to add so many reagents. So this soil may contain so many large cloud. So this cloud means these soil particles will be binded together by the help of cementing agents like organic matter, then calcium carbonate, etc. And they will form such clouds or aggregate. We will call it as aggregate. Okay. So actually, we have to remove these agents from the soil. and make the soil as a separate entity or discrete particles. So then only we will get the percentage of sand, silt and clay in the soil. So for that, first I will add H2O2, that is hydrogen peroxide. So it is a strong oxidizing agent. It will oxidize the organic matter. While oxidizing organic matter, it will be converted to carbon dioxide and it will it will be released as gas. So organic matter will be oxidized. It will be removed. So next, so it may contain calcium carbonate and oxides of iron and aluminum. These oxides of iron and aluminum are known as sesqui oxide. So calcium carbonate and oxides, sesqui oxides are removed by using dilute HCl. So I will add dilute hydrochloric acid to remove calcium carbonate and sesqui oxide. Then next I will use distilled water for filtration. For what? For removing soluble salts. This soluble salt will get solubilized in the distilled water, and while filtration, what we will get is a solution that contains soluble salt. So after drying until we can get the soil sample, that soil sample will not contain this soluble salt because it is removed by filtration with distilled water. Okay, what I will do? Then I will mechanically stir. I will give mechanical stirring to disperse the clay particles and eliminate air. So air will be removed. Okay. Then next we have to use dispersing agent. Dispersion means the breakdown of aggregate into smaller particles. So we will get smaller particles. So at last we will get smaller particles when we add dispersing agents like sodium hydroxide, sodium hexametaphosphate or carbon solution. So this question is asked in the ARS NET 2014. So what is that? Sodium, which was the dispersing agent using the mechanical analysis. So answer, it was sodium hexametaphosphate, or we can say calgon solution. It is a mixture of 40 gram sodium hexametaphosphate and 10 gram sodium carbonate. So this is very important. This one, study it. Okay, this name. Then after dispersion, what we will get? We will get ultimate particle. These particles will be dispersed or separated into ultimate particle. And by using different sieves, we will separate this different size of group like sand, silt and clay into different groups. So sieves for greater than 0.05 millimeter particles, we are using different sieves. Then for small particles, wire mesh screens are used. And less than 0.05 millimeter, we are using a sedimentation process for separating into different sizer groups. So we have seen how we are doing mechanical analysis. First, removing all the bigger particles, then organic matter oxidation with the H2O2, calcium carbonate and sesqui oxide removal by dilute HCl, soluble salt removal by filtration with the distilled water, then mechanical stirring, then using dispersing agent, then using different CUs. Okay. So there are two methods of mechanical analysis. This is a general method, and these two methods are developed: international pipette method and Boyko's hydrometer method. So we can see it in detail. The international pipette method. So it's a first we will analyze it we will take a soil suspension and allow to sediment. Soil suspension means when we dilute or when we add water to soil and stir, it will we will get a soil suspension, and when we allow it to sediment, the particles will sediment, that will come down. Okay, so by using a pipette, we are using here one pipette. So by using that pipette, we need to take samples from a given depth at specific time. So Stokes' law is a principle. That means sedimentation is a principle of international pipette method. That is, in soil solution, soils are allowed to sediment. By using a pipette, we will pipette. We will take, you all know about pipette. I don't want to say, right. Okay, so we will pipette the sample from this. certain sample like sand or silt or clay, we will pipette from a given depth at specific time. So each particles have different depth and different time. So I think that principle is like that. Uh, Different sized particles will fall at a different velocity. So if a sample of soil water suspension is taken at a depth at a particular time, it will contain all the particles which are still in suspension at that depth. So from a given depth, if I pipette it, I will get sand. So from another depth, if I pipette it, I will get silt particle. If I at different time is also important. Okay, so sand particles will fall at the same velocity, but velocity will be different from clay and silt. So in this case, at a given depth, if we pipette, the soil will contain that kind of particles only. Say like sand. So okay, then it is a standard method. Okay, it is a standard method because it has high accuracy. We are taking it directly from the depth, so we will get all the samples that is it will be the desired kind of particle. But it is time consuming because we have to wait for the sedimentation. We have to pipette it out. So when large number of samples are there, it is not usually or it is not usually employed because it takes so much time. So you say pipette to draw samples of known volume from a given depth in the suspension at specific times after sedimentation has begun. Then next is Boyko's hydrometer method. So first one is international pipette method. Then second is Boyko's hydrometer method. So uh, this Boyko's hydrometer method, one instrument known as hydrometer is used. So this principle is that there is a continuous decrease in the density of soil suspension with the time at the rate the particles fall below the level of hydrometer. So when the when the particles fall, that density decreases gradually with the time. Hmm? So the density of suspension progressively increases downward. Then, therefore, by measuring the density of soil suspension at a required time with a calibrated hydrometer, the proportion of different sized particles can be determined. So, when we insert a hydrometer, that hydrometer will measure the density of suspended soil particle. So, when we insert that hydrometer and wait for the stabilization of the soil suspension, then we can get the reading. Then hydrometers, that scale will indicate the reading. Means actually sand and clay, we will put this hydrometer at 4 minutes, while clay after 2 hours we will take the reading. Then, so within 2 hours, we can know the proportion of soil particles. So hence, this method is very fast and reasonably accurate. It is not that much accurate as the first method, national pipette method. So when the question comes like it is a fast method, we have to say hydrometer method, which is an accurate method. It is an international pipette method. So one of the limitation of this method is that it should not be used for the soil having high calcium carbonate, organic matter content, and salinity, as a material binding the soil particles are not removed in this method. So in this method, there is no separate procedure for removing calcium carbonate, organic matter, and salinity. So this method is not widely used. Then we studied the international pipette method. So it is based on the sedimentation law. That is Stokes law. So we have to learn about Stokes law in detail. So if any question comes from the Stokes law, we have to you have to note that the Stokes law that question is from Stokes law, and this Stokes law is related to the mechanical analysis. Mechanical analysis is related to what? Soil texture. So, according to Stokes' law, the terminal velocity of a spherical particle settling under the influence of gravity in a fluid of a given density and viscosity is proportional to the square of its radius. So, before explaining this, let me tell you one thing. When we are making a solid suspension and the particles will move downward. This downward movement is because it is subject to gravitation force. Actually, the upward motion because of buoyant force is less than the gravitation force. At that time, the particles will come down. It will sink. Okay. Then, so initially the velocity of the particles will increase because it is accelerating. We know when the velocity increases, the particle will accelerate, and gradually the buoyant force, the upward force, will be equal to the downward force, that is the gravitation force. So at this time, it will move with a constant velocity, and that means the acceleration will be zero. When velocity is constant, acceleration will be zero. So this velocity is known as the terminal velocity. Terminal velocity. So the terminal velocity is directly proportional to square of its radius. At a given eta means the viscosity. This term indicates the density of soil particles, and this term indicates the density of fluid. So V is equal to 2 by 9 R square, density of solid particle minus density of fluid into gravitation force, gravitation acceleration due to gravity, divided by viscosity of suspending fluid. So V directly proportional to R square. Velocity is directly proportional to square of radius of the particle. So this is what is Stokes law. And in all the laws in physics, we will assume something. All the laws are not exact because something will not follow this law. So we will assume something, some like some facts. So first, this Stokes law also have assumption because it is related to soil physics. First assumption is that particles must be spherical, smooth, and rigid. And the clay particles are plate-shaped and fall slower than spherical particles of same mass. So here, what is that? Clay particles shape is plate-shaped. So this clay particle, because of this plate-like structure, it will experience more frictional force, that is buoyancy. So clay particles velocity will be slower than the spherical particles of same mass. The first assumption is spherical, smooth. The particle should be spherical, smooth, and rigid. So clay particles, because of plate-shaped structure, this assumption we are not considering it. It is an assumption. Particles must be spherical, smooth, and rigid. Then, for understanding the next assumption, we have to learn one thing. So do you know about Brownian motion? So, just imagine that I'm keeping a tiny dust particle or say any soil particle in a glass of water, and if we observe it through a microscope, we can see these particles. But when we look the movement of this particle, we can see it is not standing, it will move. But its movement is very random. It will move here, here, like this zigzag manner. It will not move straight way, is it? So this movement is very random. So this motion is because this particle will hit this particle at that time. Because of that forcing, this will go in another direction. So it will hit to the walls of the container also. So in this case, the velocity of particles is changing. So this Brownian motion is shown by very tiny particles. So tiny particles, because of their small size, they show this Brownian motion. So this this zigzag movement is known as Brownian motion. So, very small particles like clay, what actually happens that this movement will be affected by the uh, liquid particles. So, if this is clay, liquid particles will also hit. They will hit together. This velocity will be changed. It will affect the settling and motion of the particle in that liquid. So if the size is sorry, if the size is below 0.002 millimeter, that particle will exhibit a Brownian movement. So the next assumption is that size of particles must be larger than the size of molecules of liquid, so that Brownian movement of molecules of the liquid may not affect falling velocity of the solid particle. So particle size must be larger than the liquid molecule size. So larger means there will be no Brownian movement. If there is Brownian movement also, because of this large size, it will not be much affected. So this here comes the importance of not having Brownian movement as an assumption of Stokes law. Therefore, in the gravitation field, the particles from 0.1 to 0.0002 millimeter in size can easily be determined with the discrimination method. So this size range, because they will not exhibit the Brownian movement, uh, we can use sedimentation method because it will sediment faster. But the particles with less than 0.0002 millimeter size, we will not use sedimentation method. We will use centrifugation method for separating the particles. Okay, understand. The next assumption is that fall must be unhindered. That is, if any particles have some barrier uh, when it is falling in a liquid, then their velocity will be changed. It will be decreased. So the presence of soil particles, other soil particles will affect the or hinder, will act as a barrier for the falling soil particle. Then also the soil particles will touch the wall of container. So particles falling very near the wall of container are also slowed down in their fall. Many fast falling large particles may drag finer particles down along with them. The concentration less than 3% of soil in the suspension may, however, reduce such hindrance. So, if the soil concentration is 3%, hindrance can be reduced. The particle fall must be unhindered, means there should not be a barrier for the fall. Okay, understood. And we can see the next assumption. Next assumption is that particles must be of uniform density. So density of majority of mineral particles in most soil varies between 2.6 to 2.7 gram per cc, with an average value of 2.65 gram per centimeter cube, which can be used with a reasonable accuracy. So we are using 2.65 gram. We are assuming that the particles will have a uniform density of 2.65 gram per cc. So the density also affects the falling. The next assumption is that the suspension must be still without any turbulence. That means the particles greater than 0.05 millimeter in diameter settle quickly and cause turbulence. Therefore, are analyzed using another procedure. Any movement of the suspension alters the velocity of the fall. So the suspension must be still. There should not be a turbulence. Next, there is no slipping. There should not be no slipping between the particle and liquid. Then, so remember all these assumptions. So maybe some questions will statement type questions will be asked. What are the assumptions? The particle size must be larger than the size of the liquid molecule. Fall must be unhindered. Fall must be of uniform density. Suspension must be still without any turbulence, and there is no slipping between the particles. So I hope that everyone understood why we are assuming like that. If you have any doubt, you can ask. Okay, then we can see some limitations. So first is the shape of different particles. So we know that soil supplements have different shape. So some have spherical shape, some like a clay have a platy shape, plate like a structure. And if shape is different, then they will flow with a different speed, and other properties also become different. So while we consider the whole soil, all the soil particles will not follow this Stokes law. So that is a limitation. First limitation is a shape of different particles. So next limitation is necessary to maintain constant temperature, because rate of fall is inversely proportional to the viscosity of the medium. So we have to maintain a constant temperature, and if the temperature is changed, the property of the medium also change. What the temperature change in temperature affects? It affects the viscosity of the medium. So if temperature increases, viscosity will decrease, because temperature and viscosity are inversely proportional. So the rate of fall also depends upon the viscosity. So if medium is very highly viscous, then the soil particles it fine soil particles will move. It will be very difficult for that particle to fall through that medium. Okay, so we have to maintain constant temperature. It is not possible in such a condition, like maintaining constant temperature, unless we have some instruments or some other methods for maintaining constant temperature. The next is the density of soil particles. So the soil contain many particles with a different density. Even if we assume the soil particles have uniform density, actually soil particles have different density. So all particles will not settle at a same rate, because in that terminal velocity equation, density of the soil particle, here comes a density of soil particle. So this is also important. Density of soil particles also important. So next we can see about the textural triangle. So in that process, which were uh, here in this process, I have shown that, like first method is mechanical analysis, then followed by textual triangle. So after doing everything, we have got percentage of sandy silt and clay. So next we have to use a textural triangle. So this is textural triangle. So this one is textural triangle. So you can see the percentage clay written here, percentage silt and percentage sand, and inside there is so many column or shapes, including, and it is written clay loam, silt, etc. So in this lab, so in the lab, we have done analysis, mechanical analysis. Then we got how much clay filter present in the soil. And we are using this textural triangle to determine the soil textural parts. So I can discuss it in. So okay. So for example, I have got by mechanical analysis. I have got my soil contain 40% sand, 40% silt, and 20% clay. So first, take this 40% sand. This is a percentage of sand. It is going in this direction. In this direction, is it? So where is 40%? I have to mark here. This is a 40%. So this is a direction. What we have to do? Just to draw a parallel line from 40% parallel to silt. So like, if this is the direction, we have to draw parallel to this side. Then what is the percentage of clay? It is 20%. So this is a clay side. Then here it is 20. So if we are coming like this way, in clockwise direction, what we on which direction we have to draw parallel line? We have to draw parallel to the sand. Okay. So from 20% draws one line. Hmm? Then next is silt. So I came to here. So this percentage is within how many? 40%. So here it is 40. So parallel, on which side I have to draw parallel line? On to clay. So I have drawn parallel line. So you can see these three lines met at a point. So this point, at this point, what is the loam? So our soil belongs to loam. Okay, so this textile diagram is given by ISSS. This textile diagram is according to IEEE system of classification of soil particles. So according to that system, they have given this one, this textile triangle. That I have to do by when we know the particles proportion. We have to draw a parallel line and where it intersects that point. What is the textural class that will to that soil texture our soil belongs. So there are 12 textural classes like sand, loamy sand, and sandy loam, silt loam, silt, sandy clay loam, silty clay loam, sandy clay, silty clay, and clay. Just understand that there are 12 textural classes. It is very easy to learn. Like sand, add loamy sand, then ulta karo, like sandy loam. The next is loam. So sand, loam, silt, and clay. These are common. We can make from this one. So sand, then we are adding loam to the sand, then ulta, sandy loam. Then loam, add silt to loam, we will get silt loam. Then next is silt. Hmm. So silt loam and silt, then loam. Then next is clay. So before that, next is clay. For to clay, add sandy and silty, and sandy clay and sandy silty. And to loam, what we have added first is silt loam. Silt is added, then clay is added, so we will get clay loam. Then to clay loam, we have to add sandy and silty. So we will get a sandy clay loam, silty clay loam. Then silt is separate. So total 12 texture classes is there. So this is all about today's class. I hope everyone understood this concept and feel free to ask in the comment section. And you're also all the suggestions are welcome. And please subscribe my channel for more video. If you find this video very helpful for your studies, for your preparation, you can share your views also, your suggestions. Everything is welcome. Okay. If I have to improve my way of teaching, and you can also share that. And thank you so much. Thank you everyone. Thank you so much for supporting me, and I will help you to achieve good marks. I will give concepts. You have to build your concepts. That is the main thing you need in soil science. Not like you don't want to study everything thoroughly. Like just to understand the concept. That is enough. From that concept we can frame our questions. Not question answers. Just we don't want to see the options for getting for getting answer. Just to see the question, think the concept, and you will get the answer without looking to the option. So that is what I want from you guys. Study well, prepare well, and see the video, see my previous videos also. And you don't want to read fundamentals of soil science and treatise, soil science treatise, because all from that notes I have added in this slide, I am teaching you that two books, content from Fundamentals of Soil Science and the Soil Science Treatise. So be happy and be positive. Everyone deserves success in the future. And thank you everyone. Thank you for watching, and see you in the next video.